Let's create a contingency table to calculate probabilities. The Kingdom of Eswatini is a small country in Africa. Kingdom of Eswatini has the highest prevalence of HIV cases in the world, with 28% of the population believed to be infected. Assume that there's a 99% accuracy test, that a 99% accurate test is available for HIV. Fill out the table below for a population of 100,000 in Kingdom of Eswatini. Okay, so to do this, what is the information that we know? Well, we're dealing with a population of 100,000, so we have that in our total spot. We also know that 28% of the population is infected, and the test has a 99% accuracy rate. So it's always important to start with the total column. All right, so the top is the expected number who have HIV, and the second one is who do not. Now, we have 100,000 people, and we know that 28% are infected. So if I take 28% of 100,000, that will give me an estimate of the number of people who are infected. So 0.28 times 100,000 gives me 28,000. Now think through this. If 100,000 people are total, that's our total, and we have 28,000 infected, then the rest are not infected, right? This is our estimate. So we know how many have it, how many don't. Great. There's our infection rate. Now we come to the accuracy rate. So if you have HIV, just think about this in terms of what this means. If I have HIV and I am being tested, I would expect to test positive. So that's where the accuracy rate comes in, because accuracy means correct. So that means 99% of the 28,000 people will test positive. So I take 0.99 multiplied by 28,000, and that gives me a positive test number of 27,720. Now, same idea. If I have 28,000 people who have HIV and 27,720 test positive, that means 280 test negative, because there's always that little bit of fluctuation there. Okay, now let's go to those who do not have HIV. Think about this. Okay, I do not have HIV. If I am tested, how would I expect to test? Well, if I don't have it, I would expect to test negative. So that's where the accuracy rate's going to come in. So 72,000 people do not have HIV. 99% of them are going to test negative. So that gives me 71,280. Let your common sense dictate this, right? So if I have 72,000 non-HIVers and 71,280 test negative, that means 720 will test positive. Now I add my columns, I get 28,440 total positive testers and 71,560 total negative testers. And now I have completed my contingency table, and now I can use this to calculate probability. So what is the probability of not having HIV if given a positive test result? Okay, so if, that means I'm only looking at positive results and not having HIV. Okay, well, if I'm looking at positive test results, that means my denominator is 28,440 and not HIV is 720. So when I divide those numbers, I end up with 0.025. And we call this a false positive because, right, this is 2.5% of positive test results do not have HIV. That's what this means. Okay, next question. What is the probability of having HIV if given a negative test result? So now we're talking negative results and having HIV. Okay, we can dig this. So negative, now we're looking at negatives. Total negative test is 71,560. Having HIV in that column, 280. So when I divide those numbers, I get 0.004. So roughly 0.4%. So those that test negative, 0.4% of those who test negative, actually have HIV. This is called a false negative because you test negative, but you actually do have the disease. If the U.S., okay, so now we're looking at the U.S., has a false positive probability of 0.67 and a false negative probability of 0.00005, discuss how the probabilities from Kingdom of Eswatini compared to those of the U.S. Okay, so we'll get these down here. We just found the false positive to be 0.025 and the false negative to be 0.004. And again, remember what false positive means. You test positive for the disease, but you don't have it. So in the U.S., 0.67 is roughly 2/3. So that means 2 out of every 3 people who test positive for HIV do not have it. That's what it means in the U.S. 2 out of every 3. Whereas in the Kingdom of Eswatini here, 2.5, I'll round up to 3 out of every 100. So for every 100 people that test positive, only 3 of them do not have it. Very, very different in terms of the U.S. compared to the Kingdom. Now, looking at false negatives, remember that false negative means you test negative, but you have it. Now, I have to work a lot harder. Look how small the number is in the U.S., 0.00005. So that's like out of every 100,000 people, 5 have it. That's very different. Whereas in the Kingdom here, out of every 1,000, 4 have it. Again, a lot higher rate of people having HIV, and that's what causes the big difference in the false positive and false negative rates. Would it make sense for the Kingdom of Eswatini to have mandatory HIV testing for pregnant women? We can argue both ways here. Now, you could argue yes, because it helps be able to intervene early to prevent transmission to the fetus. But that's if you have proper medical care and access to that medical care. And I don't know anything about this place. But that's true no matter where you are. Even in the U.S. where we have the medical system in place for that, not everybody has access. So you can't say it even makes sense here because not everybody has access to that medical care. So when you say yes, well, that's not really fair because HIV tends to target marginalized populations in a lot of places. And so it doesn't make sense because we're targeting people. And why are we targeting people? And so you can argue both ways depending on your stance, and there is no right or wrong answer. You just have to think through all of the different pieces that go into this and make sure that you're making an informed decision no matter where you are or what you're talking about.